Sorry, 26, had to cut that last video off. I don't know if you heard the dog bark. Okay, so plugging these coefficients or those values in as my numerators, I end up with, let's see, A is 1, B is 17, and C is 26, okay? And so now I can integrate these. First one is another natural log. So natural log of absolute value x plus 1. Second one is 17 times the natural log of absolute value x minus 2. Okay, this one is not a natural log. This is actually a u substitution where this is my u, this is my du, and this whole thing is u to the negative second du. So my antiderivative would be negative 1 u to the negative first, or in other words, so minus 26 over x minus 2, and then plus c. Okay, and then as far as what I can combine, I am going to combine my two natural logs. So I have the natural log of absolute value x plus 1 times x minus 2 to the 17th, and then minus 26 over x minus 2 plus c. Okay, last example here. We have a situation where the numerator has a higher degree than the denominator. So I'm going to start with just division. Okay, so I'm going to have 2x to the fourth minus 2x cubed plus 6x squared minus 5x plus 1, and I'm dividing by x cubed minus x squared plus x minus 1, okay? X cubed goes into 2x to the fourth 2x times. So it goes over here, multiply that, we have 2x to the fourth minus 2x cubed plus 2x squared minus 2x. Subtracting this is gone, this is gone. 6x squared minus 2x squared is 4x squared. Negative 5x plus 2x is negative 3x, and then plus 1. Bring that down, okay? And then this is my remainder, so I end up with plus all of that over all of this, which I'm not going to rewrite because I'm going to do it over here, okay? So we have that this is equal to 2x and then plus 4x squared minus 3x plus 1 all over x cubed minus x squared plus x minus 1 dx. Okay, so then to integrate, the antiderivative of this first part is just x squared, okay? And then I am going to use partial fractions on this part, okay, which means I need to factor these first. Okay, which is going to give me 2x plus 4x squared minus 3x plus 1, and then if I'm going to factor by grouping here, so I have x squared times x minus 1 plus 1 times x minus 1, so I have x squared plus 1, okay, times x minus 1, so x minus 1, x squared plus 1, and then dx. Okay, then I'm going to come down here for the algebra, okay, because I do want to split, I want to split this into using partial fraction decomposition, okay? So I'm going to have, actually 1 second here, put that down a little bit. So I'll have a linear term, so let's call that numerator a, over x minus 1, plus, and then since x squared plus 1 is a quadratic, factor, I'm going to have a linear term on top of that. So bx plus c over x squared plus 1 dx. Okay, so that's what I'm going to do with my partial fractions. Okay, so I have 4x squared minus 3x plus 1 all over x minus 1 times x squared plus 1 is equal to a over x minus 1 plus bx plus c over x squared plus 1. Okay, so then when I multiply by both denominator terms, this will cancel out on the left. So 4x squared minus 3x plus 1. Over here, the x minus 1 cancels, and I need to multiply by x squared plus 1. So I get ax squared plus 1a. And then here, the x squared plus 1 cancels, and I'm multiplying by x minus 1. So I multiply that, and I get bx squared plus cx minus bx minus c. Okay, so then, again, you can use whichever method you want. I like using the coefficients, so that's what I'm going to do here. Okay, so I'm going to look first at my quadratic coefficients, and so I have 4 is equal to a plus b. Okay, and then for my linear coefficients, I have this -3 and I have a c minus b. So -3 equals negative b plus c, just lining these up here. And then for my constant terms, I have 1 is equal to a minus c. 1 is equal to a minus c. Okay, so now I have a system of 3 equations and 3 variables. I'm going to use substitution because each of them only has 2 variables in it. So a is equal to 1 plus c, and I'm going to take that and plug it into the top equation, which is going to give me 4 equals 1 plus c plus b. So 3 equals b plus c. Okay, using that with this equation right here, okay, I have -3 equals negative b plus c. Okay, add these together, I get 0 equals, that's gone, 2c, so c is equal to 0. Okay, plugging that back in here, a is equal to 1, and then going back into the first equation, 4 is equal to 1 plus b, so b is equal to 3. Okay, so my coefficients are a equals 1, b equals 3, and c is equal to 0. Which is, having a 0 is fine. I shouldn't have b equal to 0 because I should have a linear term there, but c equals 0 is fine. Okay, so over here, oh, I didn't need to have those, I'll rewrite this. Okay, I get x squared plus the integral of 1 over x minus 1 plus 3x, and then I don't need to write plus 0, over x squared plus 1 dx, and these are both things that I can integrate. So I end up with x squared plus, this is another natural log absolute value x minus 1, and then this is not a natural log, this is another u substitution. So if I let this be u, du is 2x dx. Okay, I have a 3, so I'm going to multiply by I'm going to move the 3 to the front of the integral and multiply by 2 and then 1/2. So really I'm multiplying by 2/3 here and then a 3/2 on the front. Okay, so I'm going to have plus 3/2, and then I have 1 over u du, so the antiderivative is natural log. So natural log of absolute value x squared plus 1, and then plus c. Okay, and if you missed any of that, then you could write out the second integral and do the whole u substitution if you need to. Okay, I can combine these two natural logs. So I have x squared plus the natural log of absolute value, x minus 1, times x squared plus 1 to the 3/2, and then plus c. Bam!